Okay, hello everyone. So today we'll be doing Cannizzarro reaction. And so what is Cannizzarro reaction? It is a reaction, of course. In this, the substrate is a carbonyl compound without alpha hydrogen. The reagent is concentrated NaOH or concentrated KOH. So we can say a concentrated strong base. And the mechanism is disproportionation, and the product is the sodium or potassium salt of carboxylic acid. Okay, so here it is important to note that which oxygen and hydrogen are from the base, that is NaOH or KOH, and which is from the aldehyde, because in case of isotropic labeling in the question, things might get complicated. Okay, so the step one here is the mechanism here is mechanism here. The step one is the attack nucleophile. So a nucleophile is a nucleus loving or nucleus seeking species. It is the one which has an excess of electrons. So this is OH minus is the nucleophile over here. This attacks over here and attacks over here and forms this. The double bond here splits. Okay, transfer of OH minus iron, that is the RDS or the rate determining step. It is the slowest step of the reaction. Here what happens is the negative charge becomes a double bond, and the hydrogen group, which is a good leaving group, leaves and attaches itself to another molecule of the aldehyde, thus forming this product here. Step 3 is the transfer of proton. Here proton here refers to the hydrogen nucleus with a positive charge, because it won't have any electrons. And here what happens is that this hydrogen group leaves, positive hydrogen group leaves and attaches itself to this negative oxygen group, thus forming these two products. Okay, let's write it down. Substrate or sodium. and I threw the paper. That's it for the mechanism. This is a clear picture. Yeah, Savara. The reaction is bimolecular and follows third order kinetics. That is, two molecules will be participating in this. And if in Cannizzaro reaction concentration of NaOH or KOH is more than 60%, then it becomes fourth order kinetics. Cannizzaro reaction shows kinetic isotropic effect because CH bond breaking is part of RDS. So rate order kinetic isotropic effect, it basically means that with increase in weight of the hydrogen atom, the rate of reaction will decrease. So the rate order is kinetic isotropic effect because breaking. So here rate of reaction with hydrogen is the most, and it decreases as the weight of the hydrogen isotopes increases. So this is with deuterium and this is with tritium. Let's move on to cross carrying. That's it for the regular that's it for general Cannizzaro reaction. Let's move on to specific type of Cannizzaro reaction called cross Cannizzaro reaction. So here what happens is the reaction is between two different molecules. Here the reaction is between two different molecules, and what happens is the more reactive molecule and less hindered molecule oxidizes, and the less reactive and more hindered reduces. Okay, reduces. All right. because what is disproportionation? Disproportion is just an oxidation, and it's just a type of redox reaction, isn't it? Where one thing oxidizes, the other reduces. Okay, so that's what Cannizzaro is basically. So cross Cannizzaro reaction. Sorry, cross Cannizzaro. More reactive, less hindered. Oxidation, less reactive, more hindered. That's it for there are, we could take a few examples, but I'm not actually just referring to examples that much, so we can just view these examples. So okay, here oxidation takes place, here reduction takes place clearly, and the reactivity order of this is greater than this. Here the thing, we can clearly see that this is more reactive and it is less hindered. The less hindered, uh, referring to the kinetic isotropic effect which I described. The rate of reaction for this is much greater than this, because you see hydrogen and deuterium, and hence this is more reactive. Here these are a couple of more examples. Moving on to intramolecular Cannizzaro, this is the same as intramolecular here means the same as it meant in aldol reaction, that it happens within the molecule. There is no second molecule, it's only one molecule that takes place, one molecule in which reaction takes place. So here what happens is intramolecular, let's write the table, intramolecular Cannizzaro. So what happens here is more reactive, oxidizes, less reactive, reduces. Same thing, right? Same thing. So the basic concept is the same. कुछ भी हो जाए, like intermolecular cross this thing, cross Cannizzaro, intermolecular, doesn't matter, right? It's the same thing is just happening again and again. More reactive oxidizes, less reactive reduces. There are these 3-4 steps to mechanism, these 3-4 mechanisms, steps that you have to take care of. A thing to notice that carboxylic acid and the derivatives do not give Cannizzaro reaction. Let's keep this note. derivatives do not give reaction. Okay, so that's it for Cannizzaro. Okay, the next topic we'll be starting is haloform reaction. So haloform reaction is a reaction of tri-halo derivatives of methane, mainly, which have the general formula CHX3. The X can be chlorine, bromine, iodine. Okay, so the reaction is done with CH3 C double bond O H or R. R refers to any alkyl organic group, alkyl group. And the product and the reagent is taken as NaOH or plus I2 or NaOI. CHI3 is formed and whatever this is formed. The substrate there's a very specific set of substrates for this reaction, which are carbonyl compounds containing CH3 C double bond OH slash R, which is alkyl group, alcohols containing CH3CHOH H slash R, again alkyl group, alcohol over here, monohalide containing CH3CXHR, dihalide containing CH3XXHR, and beta dicarbonyl compounds containing this big group. These specific set of substrates is what makes it worthy of being a named reaction, you could say. Let's go on to reagents of this reaction. So the reagents here are could be NaOH plus X2, KOH plus X2, NaHCO3 plus X2, KHCO3 plus X2, Na2CO3 plus X2, NaOX, bleaching powder, which we have been studying since 9th grade, that is CaOCl2, CaOH twice plus Cl2. Yeah, that's a crazy number. There are 8 total reagents. The mechanism here is wait, I'll explain the mechanism. We'll come back to the mechanism again because it is something I'll have to explain. That is all actually. Mainly the mechanism is the biggest part of the chapter, and after that, well, there's no such, there's not much left. There are some special points related to iodoform. There are a few exceptions. It isn't chemistry, there are exceptions, as they say. Okay, so let's begin the writing part. Haloform reaction. You don't really need to write it. I don't need to rewrite all of this, right? These are just my revision notes. Let's start from substrate. The substrate is there are how many? 5 substrates. Let's try to recall them. The first is carbonyl compound containing CH3 C double bond O, CH3 C double bond O H slash R. The second is alcohol containing CH3COH H/R. Did I get that right? Say A. CH satisfying 4-1-CZ H/R group. What's the third one? Halide contain alkyl halide, monohalide. Monohalide containing CH3 CHX H/R 4s dihalide containing and our fifth and final, let's see, beta dicarbonyl compound. Oh shit, that sneeze really knocked the English out of me. Okay, containing this. Correct. That was going right. Okay. Let's go on to reagents. There are 8 reagents. X2 shit, sorry. Let's now check out the mechanism. Well, this is where we draw a line because it's tough. The mechanism is kind of wild, okay? I'm gonna warn you guys. So So let's see the reaction first. वह mechanism को अभी मारो गोली, अभी देखते हैं reaction. The reaction is C double bond O CH3 H slash R H plus I2. This must be in 4:3. This should be 4 mole NaOH and 3 mole I2. You'll find out by soon enough as soon as we study the mechanism. CHI3 plus that's the reaction. Now we come to the big leagues, the big boy of the whole sort of unit, sort of chapter. Okay, let's do this mechanism. So it's a 9-step reaction, 9-step mechanism. There are 9 steps in the reaction. Although they're pretty fun if you ask me. They are one of the easiest things to understand in organic. Trust me, I struggled a lot with it and I still do. Okay, so let's see the first step. CH2 C double bond O H slash R. This is our substrate. We take C, it's actually CH3, right? So we take one HSF just for representation. So we have OH minus here from first mole of NaOH. From first mole. That's what I'm going to write. That's from the first mole of Na. The NaOH we are using, that you can see over here, right? Here it's 4 and here it's 3. This is from first mole, this OH. So what happens is H leaves, goes to OH minus, forms water. This forms the negative charge. Now we have, what did we end up with? We end up with CH2 minus, a lot of negativity in this world. CH2 minus HR. Again, this reacts with the double X. It could be I2, it could be Cl2, it could be Pr2, anything, XX. Br, II, Cl. And we end up with CH2, C, H. You can notice that this group has remained practically unaffected. Okay. This bond breaks. Like we could show it like this breaks and this gets attached over here. This attacks over here. Okay. Like also this bond breaks like the X plus. It should be X plus, right? And then it attacks. This pura leaves. It because you think about it, if it's X minus, it won't be able to attack minus, can't attack minus. So it would be X plus and then it will attack over here. Okay, this forms. I'm heading to top of the page to you. Okay, so I'm heading to the top. Which was step 1, 2, 3. We are in the third step. 1, 2, 3. Okay, so we have here we have OH minus. That's from our second mole of NaOH. Of course, X2 won't give you OH minus, right? It's from our second mole of NaOH. This here will become H/R CH minus X. This is the same thing that happened in the first step, right? This is the exactly same thing that happened. If you can notice, wait, I'll show you. Here what happened? This H left, went to OH minus, H2O होके निकल गया, and it formed negative. Same thing here. ये एक और H वैसे ही कर दो, leaves H2O negative. This keeps on repeating. This forms a sort of a chain reaction, and this keeps on going until the reagents are exhausted. X CH X CO H. ठीक है. Again OH minus from third mole. Alright. Same thing. Again CHX C double bond O H/R minus. हो गया सब सही. Alright. Again XX. This would be the new 6-7 CX3 C double bond O H/R. Last mole. Let's go. Fourth mole. Now I'm tired of writing from, okay? Don't blame me. Fourth mole. We write OH minus COH. This attaches over here. Something special happens over here. What happened in the wait a minute. I'm right. Something special happens over here. Instead, this is a nucleophile, right? Electron rich species will attack a nucleus. What is the biggest nucleophile over here? This time it isn't the carbon with the hydrogen, because there is no negative charged carbon here. This will attack over here. This will jump over here. This will get a negative charge. This gets a negative charge. This gets a negative charge. Okay. Now this becomes OH. This becomes CX3. This becomes O minus, and this stays HR. ठीक है. Okay. So here what happens now is, to gain stability, this jumps over here, this negative charge, and forms a double bond. Yeah. Forms a double bond, and this leaves. It's stable on its own, right? CX3. So this just leaves. So this becomes more stable. Hence we get the products, the final products, that are CX3 minus plus OH C double O H/R. Okay. And this is our final product. CHX3. H gets replaced by Na over here, and there and one H adds on here to make it stable. This is a complete Haloform reaction. Let's see what are the special things about here. Here the first step is RDS. That is the rate determining steps. It shows kinetic isotopic effect, and it's the same thing over here. HT rate of haloform is equal with respect to the halogen, and there's a special reaction for COH twice plus X2 is used mainly in the reaction with beta dicarbonyl compounds.